Hi, Algebra 3 students. You will be working on the last of your linear review notes packet, and it's called Least Squares Regression Line. And so this is what it's going to look like. Let me share my screen, and here's what it'll look like. You're going to hear me refer to the least squared regression line as Lsrl, so least squared regression. All right. We're going to work the first example together in these notes, so be following along. Make sure you have Desmos open. And remember what least squares regression is. This is from your statistics unit, probably in Algebra 1. And what you're going to start with is a bunch of data. It'll always be in a table labeled X and Y. And the first step is going to be putting that into Desmos. So go to Desmos. And you're going to put this table in. Now, how do you get a table? Well, you just click on the add sign and scroll down to table, and you'll see when to add it. Now, pause the video here and add in your data table. Don't worry about that E column. We'll explain that later. You should have X1, Y1. All right, welcome back, Algebra 3. Your table should be completed, and you should have a scatter plot that looks like this. If you can't see it, you have to scroll over until you find the data points. So these are your data points. And the first thing that your notes are going to ask you to do is to explain what that scatter plot looks like using SOFA. S stands for the strength, O stands for outliers, F is the form, and A is the association. So let's go back to our notes and fill those in. All right, so SOFA, strong, you can do strong, moderately strong, or weak. This is pretty strong, meaning the lines line up in a pretty straight line. There were no outliers. If you take AP statistics, you'll learn a little bit more about determining exactly if there's outliers, but there are no outliers. The form is linear. You can have quadratic, you can have exponential form, but we're going to draw a line through this data. And then A is positive. And I want you to think about the data. As the height of a tree gets larger, the trunk should also get larger. So that's a positive association. If one gets large, the other gets large. Now, part B is asking for the Lsrl. So what is the best line that you could possibly draw through this data? And that's the best line of the best lines. You can't beat this line. So go back to Desmos. And all you have to do is click in the box that says number 2, just like what I'm doing. And you have to type in Y1 because your table is listed as Y1. Then you have to do the tilde or the squiggle, and where you find that is right above the tab key on your keyboard, and it'll be shift squiggle, and then it'll be MX1 plus B. And that is the best possible line you can draw through that data set. And if you look down here at the bottom, this box gives you everything that you need. It gives you your parameters, which is your M and your B. So we now know our M and our B. I've been rounding to the nearest 10th or 100th, and let's go in and fill in that least squared regression line. So back to your notes, and the least squared regression line is 0.48, I rounded. I put the over 1, because you'll see why here in a minute. And then our y-intercept was a negative 24.1. So that's the equation of the line. Remember, that's the best line that you can draw through that data. Okay, let's look at the next 3. So you have to be able to interpret what the slope means, the y-intercept, and then comment on that residual plot. So you can't just tell me the slope is 0.48. You have to be able to interpret what that means. So my suggestion is to write out the slope in terms of units. So I did that here. Remember, it's the change in y over the change in x, so it's 0.48, and that represents the diameter and a height of 1 foot. And so the way you interpret that is, I always start with the denominator, and so for every 1 foot a tree grows, the diameter grows about 1/2 foot, okay? That's how you interpret that. It really helps me to write out that equation here because with the units, because then it's really easy. Every time it grows in height, the diameter gets bigger. You have to use the height and diameter, and you have to use the 1 and the 0.48. I'm looking for numbers and for units, okay? So again, in the context of the data, interpret the y-intercept. So the y-intercept is a coordinate point. So write out your coordinate point. It's 0, negative 24.1. 0 stands for the x, and the negative 24.1 is the y. So when a tree is 0 feet tall, the diameter is a negative 24.1 feet. It doesn't make any sense. How can a diameter be negative? Well, just write it like that and then tell me that doesn't make sense because it's an extrapolation error. We'll talk a little bit more about extrapolation in class, but yeah, sometimes your y-intercept really doesn't make sense. It's okay, just interpret it and explain it. Now the residual plot. Okay, we're going to go back to Desmos. Okay, so click back here on Desmos, and then where it says that E1 in the bottom left, click on E1, and you will get this guy. Those are all of the residuals. And the residuals just tell us how far away our model or our line is from the actual data. And so look at the blue dots on my screen. That's the residual plot. What we want is like a shotgun pattern. It needs to be very scattered, which it is, which is a good thing. If you have a nice curve in there, that means a line probably isn't a good model. So you want it to look very random, very scattered. Then you know a line is going to be a really good model. So let's go write that in our notes. Okay, the residual plot is scattered. There's no curved pattern. This means that a line is a good statistical model to use. That's all you have to say when it says comment. Now, if you get a really nice curve or you get a nice pattern, then that means a line probably isn't going to work. All right, let's look at the last 3 questions. The whole point of getting the Lsrl is to be able to make predictions. So we created a model, the least squared regression line, and now we're going to use it. So let's say we have a 100-foot tree. How tall or how wide is that diameter going to be? Well, you're going to plug in 100 for x and solve. So all you're doing is y equals mx plus b, but now you know the x. It's 100 feet. So you could see it'd be about 23 feet. That's a really big tree, but that's the way it would be. Okay. Again, this is our prediction. Does that mean every 100-foot tree would it be exactly have a diameter of 23.9 feet? No, that's not what that means. Okay. It just means that's our prediction. Okay, so let's use the Lsrl in the backwards. What happens if I had a trunk, I found a tree with, that is incorrect, it should be 5 feet, guys. That's a typo. So what happens if you find a tree that's has a diameter of 5 feet? Can you make a prediction of how tall it was? Sure, but this time you let y equal 5, and then you solve, okay? So I want you guys to stop here and see if you can solve, and then we'll talk about that in class. Okay, last question. What is the value of the residual for the 85-foot tree? So remember, we're going back to Desmos. Residuals just tell us how far away our line is from the actual data. So I'm looking here at 85. I'm looking at that point right there. How far away is it? Well, you can calculate that. It's just the equation is actual minus predicted value, your y values. But in Desmos, once you click that, it's right here. And for 85, it's a negative 1.770914. Okay? That's the distance between that point and the red line. All right, let's go in and put that into our notes. So Desmos, our residual is negative 1.770914. What that means is that our prediction or our model over predicted for that diameter of an 80-foot or 85-foot tree. It means, whoops, we were a little bit off. We over predicted it was going to be, our model said it was going to be taller than it really was. But that's okay. That's what statistics is about. We give a prediction and we're close. Okay. This was a pretty fast example. You might have to stop and watch it a couple times, but now I want you to go try one on your own. On the back of your note sheet is a second example. The questions are exactly the same as these questions. The only difference is the data set. So try that second question. We're going to go over it in class, so bring your questions. Good luck, Algebra 3.